Dear students, so in this lecture, let me explain B tree. Before getting into the B tree, let's just compare the B tree with the B plus tree. Just let's first go through the structure of the B plus tree, then it will be easier for us to understand B tree. So as I already said, so plus it represents something addition to the B tree is nothing but B plus tree. Okay. So first let's look at the structure of a B plus tree. This is a typical B plus tree example. So in this, if you watch, if you take the leaf node, there will be a pointer between one leaf node and another leaf node. So this is 1, 2, 3, 4. 1, 2, 3, 4. So actually the B plus tree uses this property to make us or to facilitate us to retrieve all the values that has been inserted in the B plus tree in a single or in a simple way. If you look at this tree, the values present in the leaf node or the values that has been inserted in the tree. So if you come to the leaf node, if you take the first value, you can just go to the second value and then the consequent node, that is consequent leaf node, that is 5. In that 5 8 is there, and then if you go to the next node, it will be giving 11 17 20 23 25. So if in this situation, if you want all the datas inserted in the tree to be retrieved, then you can just simply go to the leaf node and you take all the values. And another one thing, if you see here, some the values uh, in the nodes other than the leaf nodes would have been repeated in the leaf node. For example, here the 11, the value 11 in the internal node is reflected in the leaf node. So this is done to facilitate what I have said earlier. So, so the maintaining an extra copy of the values in the internal node again in the leaf node the facilitates the situation in which we need all the nodes to be retrieved. So this you could understand, and you can better understand when we compare it with the B tree. So this you keep in mind, the structure if you keep in mind, and when we go to the B tree, so here you won't find any pointers between the leaf nodes. There will be no pointers. So that means there will be only a single copy of a value will be maintained in the B tree. So no duplication or the leaf node containing the pointers will be found here. It's just like a normal binary search tree in which the values will be dispersed among all the nodes. So if you want 8, if you want 8, you have to come here from 13. Then you have to come here and then greater than 8. So the values will be available, or the values will be available only once in the uh, throughout the entire tree. But in the B plus tree, you will be having 2 copies. So that's 2 copies in the sense the all the values whichever in the root node and internal nodes, again it will be there in the leaf node. So here, suppose if I want 17, if I come to the leaf node, the 17 will not be here. So in the B plus tree, like in the B plus tree, you cannot just take all the elements in a single take. So if you want 17, then you have to visit 13 and then here you have to go 70. Suppose if you want in all the elements in the tree, then you have to start from the root node, then you have to come to the values lesser than the root node, and then after collecting all the values you have to go to. So the searching becomes what uh, complex here. Complex in the sense, compared to the B plus tree, additional searches has to be carried on for locating or for accessing all the elements. So these are all the general things that you must know. But in the exam point of view, just you have to see the question. So what they have given as values and orders in the question. So based on that two questions only, we are just going to solve the problems or or we have to give the solutions, or we have to write draw the B tree for getting good marks. So here they have given the values as 20, 10, 30, 15. So these are all the values that has to be inserted in the B tree. Okay, so here also they have given the same thing, whatever they have given in the B plus tree, the same thing will be given in the question. And then while drawing the tree alone, we have to differentiate the trees and show. So if it is, if we are just go, if they have asked B plus tree, we two things we need to do. One is we have to maintain an extra copy of the values in the leaf node, as well as the leaf node should be interlinked together, so that coming to the B plus tree, you have to ensure these properties. In the while if they ask to draw B tree, these two you have to avoid. No duplicate values should be there, as well as no pointers between the leaf nodes. So then it will be easier for us to construct a B tree. So first what we are doing here, they have given the order as 3. So if the order is 3, then the node will be having 3 pointers. So pointers equal to 3, and then values will be 3 minus 1, that is order minus 1, it will be 2. So that's what they have written in the first step. They have created a node with 3 pointers and then 2 values. So since in the initial stage 2 spaces will be there, then we are taking the first two elements 20 and 10, we are arranging it in ascending order, then we are inserting. So and then the third element 30 we are trying to insert here. Already 2 elements are there, so it is not possible. So the same method, that is we are taking 10, 20, 30, and we are finding the middle element, and it will be occupying the topmost position, and the lesser value will be coming to the left side, and the greater value will be coming to the right hand side. So and then after 30 we are trying to insert 15. So while comparing here, actually the 15 will be lesser than 20, so it comes here. So it's simple. So and then we are trying to insert 12. So 12 in the sense it's lesser than 20, so 12 should have come here, but since already 2 elements are there, we cannot insert there. So we are again breaking this. Here 12 will be coming lesser than 12. Here we cannot insert. Since the 12 cannot be inserted here, then we are finding the same middle element, so 12 goes upper side. So then the tree is structured here. So we are trying to insert 12 here. Since it cannot be accommodated, we are moving it to the upper side. So then 12 will be coming here and 20 will be going there. Again we are just 12, 20. So elements that are lesser than 12 are placed to the left hand side. Between 12 to 20 will become greater than x. So then we are trying to insert 40. Since 40 is greater than 20, here the place is there, so the 40 is accommodated here. So and then we are trying to insert 50. So the previous tree we are just trying to insert 50. 50 is greater than 20, so it comes here. So again there are 2 elements already there in the node. We cannot insert the third. Again, what we are doing is we are trying to insert here. So the 50 goes here. Again, there are two elements. The same situation happens here. Then we are pushing the third element, that is 12, 20, and 50. So the middle element is 20. The 20 comes the upper side, and the and this level lesser than 20 is 12, and then greater than 20 is 40, and the elements that's coming under 40 uh, are placed here, and then greater than 40 are placed here, and it's lesser than 12 are placed here, greater than 12 are placed here. So compared to B tree and B plus tree, B tree is the simplest tree because it doesn't involve any duplicate values, and additional pointers are not used in the B tree when compared with the B plus tree. So this they have, so in this is the differences they have mentioned here. So in the B plus tree, you can store both the keys and data in the internal and leaf nodes. So, but you have to store the data in the leaf nodes only. So that's what. So if you store the data in the leaf nodes in B plus tree, then in a single stretch, you can take all the elements from the leaf nodes. But here you shouldn't do like this. Instead, you have to store the values in a dispersed manner. So the leaf node cannot, that's what I said is the leaf node cannot be a linked list. The leaf nodes are connected using linked list. Searching becomes difficult. What I said, since the leaf node is not linked, compared to B plus tree, B tree, in the B tree, the searching becomes difficult. So in the B plus tree, since the pointers, that's what I said, because all the data are found in the leaf nodes, it will be very easier to retrieve all the nodes. So B plus tree do not store any redundant search key value. B plus tree, there will be redundant search values. So that's it. Thank you.